Hello students, today we will study energy changes in reactions. Students, we know very well that during a chemical reaction there is always an energy change. Right? There is always an energy change during a chemical reaction. Energy is given out or taken in. Sometimes energy is absorbed or sometimes energy is released during a reaction. And the energy is usually in the form of heat. So reactions can be divided into two groups, exothermic reactions and endothermic reaction. Exo, as the name indicates, exit. It means energy is given out or energy released during the reaction. Energy released during the reaction. Endothermic reaction, energy absorbed during the reaction. Exothermic reactions give out energy, so there is a temperature rise. There is a temperature rise during exothermic reaction. Examples of exothermic reactions. Reaction between iron and sulfur. Reaction between iron and sulfur, it gives iron sulfide. Right. To start of the reaction between iron and sulfur, you must heat the mixture. Right? But as you heat the mixture, as soon you heat the mixture, it glows red hot, even without the Bunsen burner. What you may observe some red hot, right? It starts glowing even without the Bunsen burner. Okay, it means something is here that makes it glow. It is because of rise in temperature. It is because of high temperature. It means energy is releasing during the reaction. It means energy is given out during the reaction. Energy released during the reaction. Next example is mixing silver nitrate and sodium chloride solution. Mixing silver nitrate and sodium chloride solution. It gives white precipitate of silver chloride. It gives white precipitate of silver chloride and a rise in temperature. See, here we mix silver chloride and here we mix silver nitrate and sodium chloride. We mix silver nitrate and sodium chloride and it gives white precipitate. See, this is the white PPT. It gives white precipitate of silver chloride. Right? I'm going to repeat it. What we mix here, silver nitrate and sodium chloride, it gives a white precipitate of silver chloride and a rise in temperature. Next example is when you add water to lime. When you add water to lime, that is calcium oxide, heat is given out, so the temperature rises. See, here the rise is being measured by this instrument, right? These reactions can be described as reactants converted into products and there is a release in energy. Right? Energy released during the reaction. How do you know whether energy is released or energy is absorbed? By seeing the reaction. When the energy is written on the product side, it means energy released during the reaction. The total energy is the same on each side of the arrow in a reaction. So in exothermic reaction, the products have lower energy than the reactants. Look here, the energy of reactant is more than the energy of product. So here, the energy of product is less and energy of reactant is high. Okay, so this is energy level diagram for an exothermic reaction. The products have lower energy than the reactants. The energy change. Energy is measured in kilojoule for reaction A above, right? Here in this reaction, what we are observing, iron plus sulfur gives iron sulfide and there is energy change minus 100 kilojoule. This minus sign indicates that the reaction is exothermic. Here we can observe that 100 kilojoule of energy is given out when the amounts of reactants in the equation. Here 56 gram of iron and 32 gram of sulfur reacts and minus 100 kilojoule of energy is released. or given out. So it is exothermic reaction. Minus sign shows that the energy is given out. Other examples of exothermic reactions. All these are exothermic, the neutralization of acids by alkalis. Neutralization of acids by alkalis, the combustion of fuels, burning of fuels. Neutralization means when acid reacts with alkalis, it gives salt. Right? When we burn fuels to obtain heat for cooking, heating homes, and so on, the more energy they give out, the better. Respiration in your body cells, it provides the energy to keep your heart and lungs working and for warmth and movement. Let's talk about endothermic reactions. Endothermic reaction means in which energy is absorbed during the reaction. Usually, when bonds are breaking, energy is absorbed in the reaction. Endothermic reaction are bond breaking reaction, and exothermic reaction occurs during the formation of reaction, during the formation of bond. I would like to repeat it. Endothermic energy is absorbed when bonds are broken, and energy is released, energy absorbed, energy absorbed when bonds are broken. Okay, and when energy released during the formation of bond, right? During the formation of bond. Okay. Examples of endothermic reaction: reaction of barium hydroxide and ammonium chloride. Reaction of barium hydroxide and ammonium chloride. Okay. Look here, it is very interesting experiment. When barium hydroxide reacts with ammonium chloride, the temperature falls so sharply that water under the beaker will freeze. Look here, water here has frozen to ice here. Water will freeze. Water will become ice, frozen water. Because the energy from this wood enters into the system, right? Energy from surrounding enters into the reactants or the system. So energy is absorbed. Energy absorbed during the reaction. Next is reaction of citric acid with base sodium hydrogen carbonate. See, there is a candy that is a combination of citric acid plus the base sodium hydrogen carbonate. It is a combination of citric acid is C6H8. You don't need to remember it. And it's a combination of sodium hydrogen carbonate. Right. So when you taste it, you may feel a cold sensation in your tongue. Right. It occurs because of neutralization reaction that occurs on your tongue. What happens here? The energy from your tongue enters into the reactant mixtures. So because the heat is absorbed, right? Heat is absorbed from your tongue. So you may feel a cold sensation in your tongue, right? Neutralization that occurs takes in heat. So your tongue cools. What happens? Energy absorbed, right? Energy absorbed. Heat energy from your tongue goes inside the reaction mixture. Reaction mixture of citric acid plus sodium hydrogen carbonate, because this candy is made of sodium hydrogen carbonate and citric acid. Now you may feel a cold sensation in your tongue because the heat energy from your tongue enters into this reaction mixture. Next is heating of calcium carbonate. The crucible contains calcium carbonate. Okay. When you start heating it, it will all decompose to calcium oxide and carbon dioxide, right? So we may see that heat energy is given by Bunsen burner to the to the crucible, and from crucible it is given to the calcium carbonate that is present inside the crucible. So here it is an here we can observe it is an endothermic reaction because heat energy is absorbed. These reactions can be described as reactant plus energy. We can see energy is absorbed here, right? Because it is on the reactant side and it gives products. So the energy is transferred from the surrounding and D from the air and wet wood. Look here, from air and in wet wood. So here absorption of energy. Here also energy is absorbed. Okay. And in E from your tongue and in F from the Bunsen burner, right? In all examples, we can see that energy is absorbed. Since energy is taken in, the products must have higher energy than the reactants. We can see this in energy level diagram. See, the energy of reactant is lower than the energy of product. So product's energy is on higher side, higher energy. The energy of product is higher than the energy of reactant because energy is absorbed during the reaction. Energy change. For reaction F, the crucible contains calcium carbonate. If you keep on heating, it will all decompose to calcium oxide and carbon dioxide. CaCO3 gives calcium oxide and carbon dioxide, and here energy change is positive, plus 178 kilojoule. This plus sign indicates that the reaction is endothermic. Energy is absorbed during the reaction. So we can see here that 178 kilojoule of energy is needed to make 100 gram or 1 mole of CaCO3. The plus sign shows that energy is taken in. Other examples of endothermic reactions. See, D and E, both are spontaneous reaction. They start off on their own. Water here has frozen to ice. And here, tongue cools because energy is absorbed from the tongue to the this candy, right? That is a sherbet. But many endothermic reactions are like F. The crucible contains calcium carbonate. If you keep on heating, it will all decompose to calcium oxide and carbon dioxide, where energy must be put in to start the reaction and keep it going. For example, reaction that take place in cooking, photosynthesis. These are the example of endothermic reactions. Always remember exo means out, endo means in.